Deep within Earth's belly, a primal force slumbers. It is a force of immense scale, capable of unleashing devastation unlike anything humanity has ever witnessed. These are not your everyday volcanoes, spewing forth lava in fiery spectacles. No, these are supervolcanoes. Cauldrons of molten rock so vast, their eruptions can reshape continents and darken the skies for decades. Imagine a volcano, not with a cone-shaped peak, but a caldera so wide it could engulf entire cities. Imagine eruptions, not in terms of days or weeks, but centuries of fiery chaos. These are the hallmarks of supervolcanoes, geological titans that have left their indelible mark on Earth's history. These slumbering giants are a stark reminder of the immense power that lies beneath our feet. They are a testament to the fact that Earth is a dynamic, ever-changing planet, capable of both breathtaking beauty and unimaginable destruction. And while their eruptions are mercifully rare, the threat they pose is very real, a stark reminder of our planet's awesome power. Supervolcanoes are not your typical volcanoes. They are not defined by their size or shape, but by their eruptive power, measured on the Volcanic Explosivity Index, or VEI. A volcano earns the super prefix by unleashing an eruption of magnitude 8 on the VEI, the highest rating, signifying an apocalyptic event. These super eruptions are characterized by the expulsion of over 1,000 cubic kilometers of material, ash, gas, and rock, in a cataclysmic event. To put that in perspective, the 1980 eruption of Mount St. Helens, a significant volcanic event, ejected a mere 1 cubic kilometer of material. Yellowstone National Park, a geothermal wonderland, sits atop one such supervolcano. Its caldera, a massive crater formed by a past super eruption, spans a staggering 30 by 45 miles. Other notable supervolcanoes include Long Valley Caldera in California and Lake Toba in Indonesia, each a testament to the awesome power hidden beneath Earth's surface. These geological giants are a stark reminder that Earth's history is punctuated by periods of intense volcanic activity, events that have shaped the planet we know today. Supervolcanoes are not your typical volcanoes. They are not defined by their size or shape, but by their eruptive power, measured on the Volcanic Explosivity Index, or VEI. A volcano earns the super prefix by unleashing an eruption of magnitude 8 on the VEI, the highest rating, signifying an apocalyptic event. These super eruptions are characterized by the expulsion of over 1,000 cubic kilometers of material, ash, gas, and rock, in a cataclysmic event. To put that in perspective, the 1980 eruption of Mount St. Helens, a significant volcanic event, ejected a mere 1 cubic kilometer of material. Yellowstone National Park, a geothermal wonderland, sits atop one such supervolcano. Its caldera, a massive crater formed by a past super eruption, spans a staggering 30 by 45 miles. Other notable supervolcanoes include Long Valley Caldera in California and Lake Toba in Indonesia, each a testament to the awesome power hidden beneath Earth's surface. These geological giants are a stark reminder that Earth's history is punctuated by periods of intense volcanic activity, events that have shaped the planet we know today. The eruption of a supervolcano is a global catastrophe with far-reaching consequences. The immediate impact is devastating. Ash and rock blanket the landscape for hundreds of miles. Pyroclastic flows incinerate everything in their path. These flows can travel hundreds of miles. The true horror lies in its long-term effects. Ash and sulfur dioxide can trigger a volcanic winter. Sulfate aerosols reflect sunlight, causing temperatures to plummet. This can lead to crop failures and famine. Reduced sunlight disrupts ecosystems, causing extinctions. A supervolcano eruption is a global reset button. Earth's history is a testament to the devastating power of supervolcanoes. These eruptions have left their mark on the geological record, providing stark reminders of the planet's violent past. One such example is the Toba eruption, a cataclysmic event that occurred approximately 74,000 years ago in what is now Indonesia. Toba ejected an estimated 2,800 cubic kilometers of material, plunging Earth into a volcanic winter that lasted for several years. Some scientists believe that the Toba eruption had a profound impact on human evolution, creating a genetic bottleneck that nearly wiped out our species. Evidence from ice cores and geological deposits suggests that the eruption caused a significant drop in global temperatures, leading to a period of prolonged environmental stress. Another example is the La Garita caldera eruption, which occurred in what is now Colorado approximately 27.8 million years ago. This eruption, one of the largest known volcanic events in Earth's history, ejected an estimated 5,000 cubic kilometers of material, forever altering the landscape of North America. These ancient eruptions serve as a stark reminder of the awesome power of supervolcanoes and the very real threat they pose to life on Earth. Section 5. Unmasking the Beast. Science at the Heart of the Inferno. Understanding supervolcanoes is critical to mitigating their potential impact. Scientists employ a variety of techniques to monitor these slumbering giants, hoping to glean insights into their behavior and predict future eruptions. Seismographs are used to monitor ground movement, as magma rising within a volcano can cause subtle tremors. GPS stations provide even more precise measurements, detecting minute changes in the Earth's crust caused by magma movement. Gas emissions are another important indicator of volcanic activity. Scientists analyze the composition and volume of gases released from volcanic vents, looking for changes that might signal an impending eruption. For example, an increase in sulfur dioxide emissions can indicate that magma is rising within the volcano. Geologists also study the deposits from past eruptions, piecing together the history of a supervolcano's activity. By analyzing the layers of ash and rock, they can determine the frequency and magnitude of past eruptions, providing valuable insights into the volcano's future behavior. Section 6. Predicting the unpredictable. The quest to foretell fury. Predicting volcanic eruptions, especially those of supervolcanoes, is a complex and challenging task. While scientists have made significant strides in understanding these geological giants, much remains unknown. One of the biggest challenges is the infrequency of super-eruptions. With events occurring on geological timescales, tens of thousands or even hundreds of thousands of years apart, there is simply not enough historical data to develop accurate predictive models. However, scientists are making progress. By combining data from seismic monitoring, gas analysis, and geological studies, they are beginning to develop a better understanding of the conditions that lead to super-eruptions. For example, scientists believe that a key factor in triggering a super-eruption is the buildup of pressure within the magma chamber. As magma rises from deep within the Earth, it can become trapped beneath the Earth's crust, causing pressure to build. When this pressure exceeds the strength of the surrounding rock, a massive eruption can occur. While predicting the exact timing of a super-eruption remains elusive, scientists are confident that with continued monitoring and research, they will be able to provide advance warning of these devastating events. Section 7. Yellowstone, a supervolcano in our backyard. Yellowstone National Park, a geothermal wonderland of geysers, hot springs, and bubbling mud pots, sits atop one of the world's most closely watched supervolcanoes. Its caldera, formed by a massive eruption some 640,000 years ago, is a constant reminder of the immense power that lies beneath the surface. The Yellowstone supervolcano has experienced 3 known super-eruptions in the past 2.1 million years, each one drastically reshaping the landscape of North America. The most recent eruption, 640,000 years ago, ejected over 1,000 cubic kilometers of material, covering much of the western United States in a thick layer of ash. While Yellowstone is not currently showing signs of an impending eruption, it is considered an active volcano, and scientists are closely monitoring its every tremor, rumble, and exhalation. The Yellowstone Volcano Observatory, a collaboration of government agencies and research institutions, keeps a watchful eye on the supervolcano using a network of seismometers, GPS stations, and other instruments to track its every move. The data collected from Yellowstone is not only crucial for understanding the behavior of this particular supervolcano, but also for developing predictive models for other supervolcanoes around the world. Section 9. Living in the Shadow of Giants, Preparedness and the Future. Supervolcanoes are a fact of life on Earth, shaping our planet for billions of years. Their rare eruptions remind us of the balance between creation and destruction. Preparedness is key to mitigating their impact. This includes scientific research and early warning systems. International cooperation is crucial. Sharing data and resources helps us prepare and respond. Understanding our planet's fury teaches us to respect its power,